Hello everyone. Here's a video on stoichiometry and calculating stoichiometric problems. The secret to stoichiometry is using moles, okay? And it's the process is I can use a balanced equation to convert from one thing in an equation to anything else in that equation using this concept of moles and what you see in red in front of you, a mole ratio, okay? So a mole ratio is actually very important. So when we take a look at a balanced equation, which is right here, so if I have a balanced equation, I'm sorry, this equation is not balanced, so I need to put a 2 in front here and a 2 in front here, and I believe that does it, okay? So now I have a 2 to 1 to 2 to 1 ratio, okay? Now, typically ratios, actually always ratios compare two things. So I have a 2 to 1 ratio of reactants. I have a 2 to 2 ratio or a 1 to 1 ratio of sodium fluoride to sodium hydroxide. I have a 1 to 2 ratio of this reactant to this product, and etc. So I can use any ratio I want to get whatever product or reactant I'm looking for, okay? The steps to stoichiometry are right here. And this is very algorithmic. If you can follow these 4 steps over and over and over again, you'll be just fine. Think of it as a checklist or a roadmap. I don't care how you think of it, just these 4 steps are always important, or what you use. So when I look at these, it says the steps of stoichiometry, the first thing is balance the equation. Well, we did that last chapter, so that's cool. That's easy to do. The second thing is convert given quantities to moles if needed. Again, we're going to convert to moles. So step 2 is convert to moles. Convert to moles, get moles, get moles, get moles. We've done that many times already. The third thing is the new step, and that's the mole ratio, and that's going to be moles of something over moles of something. Sometimes you guys call it the mole to mole ratio. It's really not called that, but I get why you call it that. And number 4 is you're going to convert back to mass or volume or whatever. So step 2 and step 4 are in red because sometimes they're already done for you. So again, these 4 steps, 1, 2, 3, 4, every single time, and it works. So if you have to refer to this, go back to this slide, but let's try a couple problems. So it says I have 1.5, if 1.57 moles of oxygen reacts with hydrogen to form water, how many moles of hydrogen are consumed in this process? So the first thing we got to do is write a balanced equation. So oxygen reacts with hydrogen to form water. Balance the equation. I need a 2 here and a 2 here. Okay, good. How many moles of hydrogen are consumed in this process? So what I always tell you guys is write down what you know. We have 1.57 moles of oxygen. Okay? Now notice step 1 is balance the equation. Done. Step 2 is convert your starting materials to moles. Done. I'm already in moles, so don't go any further. All right? So that's done. Step number 2 was done for us this time. Step number 3 says use a mole ratio. Well, the ratio always includes what you start with and what you're going to. So I'm starting with oxygen, and I'm going to hydrogen. Okay, so moles of oxygen on the bottom to moles of hydrogen on top. So this is the mole ratio. This is step 3. So step number 1 was right here. Step number 2 was done for us. Step number 3 is always done. That's the essence of stoichiometry, is the mole ratio. So if I have moles of O2, now again, these come from the coefficients. So you'll notice I'll put a 1 here and a 2 here. Where did those come from? The 1 comes from this coefficient here, and the 2 comes from this coefficient here. Since there's only one way to balance this equation accurately in the lowest whole number terms, we can use these ratios with effectiveness, okay, with surety, okay? So it says how many moles of hydrogen are consumed. So moles of hydrogen, moles of hydrogen. I'm in moles of hydrogen, so I'm done, okay? I don't have to go to step 4 because step 4 says go to mass. It's asking for moles, so I went through all 4 steps. I completed the 4 steps of stoichiometry, and all I need to do is calculate, and that's 1.57 times 2 gives me 3.14. Label it correctly. Moles of H2 were consumed in order to make this reaction tick. Okay? Let's try another one. Okay, the decomposition of potassium chlorate, ClO3, produces potassium chloride and oxygen gas. So let's balance the equation. Chloride. Okay, so I need a 3 here, I need a 2 here, and a 2 here. So that's balanced correctly. How many grams of oxygen can be prepared from 4.5 grams of potassium chlorate? So if I have 4.5 grams of KClO3, Let's go. So step number 1 we did. Step number 2 I have to do. I'm not in moles, but I have to get to moles. Okay, so that's just a mass to moles conversion. So the molar mass of potassium chlorate, we have to add that up. Let's see, potassium's 39.1 plus chlorine, which is 35.5, plus 3 oxygens is 16 times 3, that's 48. So the total is 122.6. Okay, I can use all those numbers. Grams of KClO3, KClO3, 1 mole of KClO3. Okay, so that's step number 2. That's done. Check. Step number 3 is the mole ratio. You always have to use the mole ratio because the question says if you start with potassium chlorate, it says if you start with potassium chlorate, how many grams of oxygen can be prepared? So I'm going from potassium chlorate to oxygen now. Okay, so again, using the mole ratio, which is always being done, which is always needs to be done, that's step 3 of stoichiometry. I have moles of potassium chlorate on the bottom to match that. And I have moles of oxygen on top because that's what the problem is asking me for. Okay, now all we got to do is fill in the coefficients. So I'm going to put the 2 here, down here, and I'm going to put the 3 here, here. Okay? Okay, so let's continue. Do I have to go to step 4? Let's just make sure here. How many grams of oxygen? Grams of oxygen. Convert to mass. That's step 4. Yes, we do. So now I'm back to 1 mole. I'm back to 1 mole. So the only time, I didn't say this before, but the only time you could have a number other than 1 is in step 3 of the mole ratio. It might be 1, depending on the coefficients, but that's the only step you could have a number other than 1. Notice step 2, we're back to 1. Step 4, we're back to 1 mole. Okay? And 1 mole has a mass of 32 grams of oxygen. That's 16 times 2. So all we have to do is calculate now. 4.50 divided by 122.6, press equals, times 3, press equals, divide by 2, press equals, times 32, press equals, you end up with 1.76 grams of O2 produced. Okay? Okay, so that's that problem. I think we have time for at least one more. Let's get rid of this. Okay, so solid lithium hydroxide is used in space vehicles to remove carbon dioxide exhaled by astronauts. The lithium hydroxide reacts with gaseous carbon dioxide. So lithium hydroxide. This is all information up here. The problem starts here. So lithium hydroxide, that's +1 -1 to give me that, reacts with gaseous carbon dioxide to form solid lithium carbonate, and that written correctly. Of course, you're using your ion sheets, right, guys? And liquid water. Okay. So writing those things correctly utilizes your ion sheets. Sometimes if you miss those, you miss the whole problem, so make sure you do that correctly. This is still step 1, by the way. So I need a 2 here. That gives me, that should do it, guys. That balances that equation. So step number 1 is done. Step number 2, if I have 1 gram of lithium hydroxide, it says how many grams of carbon dioxide. So I'm going from mass to mass, okay? Grams of lithium hydroxide, but I want carbon dioxide, so stoichiometry takes care of this, okay? So grams of lithium hydroxide, I need to add up lithium hydroxide, so that's 7, that's the molar mass of lithium, plus 16 plus 1 is 24. 24.0 grams of lithium hydroxide is on the bottom to 1 mole. Notice I'm at 1 mole of lithium hydroxide. Remember, the only time you could get a number other than 1 is in step 3. Well, that was step 2. This is step 3, the mole ratio. You always have to do the mole ratio. It's how you go from one thing in a balance equation to another. So if I have lithium hydroxide, there's a 2 here. So let's put the 2 down here. And what does it say? How much carbon dioxide? How many grams of carbon dioxide? Yes, so that's a 1 there. So let's put a 1 mole of CO2 here. It says how many grams? I have to go to step 4. No matter what, I'm back to 1 mole. And when I add up a carbon and 2 oxygens, you end up with 44.0 grams of CO2. And now you just plug through here. So the way I'm going to do this is 1 divided by 24. Don't forget to press equals. Divided by 2, press equals. Times 44, press equals. 0.917 is my final answer. Okay, 0.917. All right, so that's stoichiometry. We're going to apply more of it later, but that's good for now. If you have any questions, go ahead and ask or email or whatever.